Hello students. So today we will start with chemistry 1's chem 1 solid state chapter. Basically there are three physical state: solid, liquid and gaseous state, and these three states, physical states, are interrelated with each other because of two physical properties: temperature and pressure. When we apply high temperature to solid state converted to liquid, which is known as melting or fusion. Again we provide heat to liquid state, liquid converted to gaseous state, which is known as evaporation. Gaseous state, when we lower down temperature and apply high pressure, gaseous state converted to liquid state. Again we apply high pressure and lower down temperature, liquid state converted to solid state, which is known as freezing. And these three physical states are interrelated with each other because of second factor is intermolecular force of attraction. Intermolecular force of attraction in solid is very high, in liquid state it is intermediate between solid and liquid state, and in gaseous state it is negligible. Basically there are two types of solid. So in this chapter only we will study the properties of solid, and specifically for crystalline solid. So solids are classified into two types: crystalline and amorphous. Crystalline solids means they possess a definite shape. Amorphous, irregular shape. Definite shape means all constituent particles, atoms, ions or molecules arranged in a definite regular pattern. Here range of regularity is very less, irregular pattern is there. Crystalline solid possess sharp melting point. Amorphous solids will melt over a range of temperature because uneven distribution of heat takes place. Crystalline solid exhibit anisotropy. Anisotropy means some physical properties will change when we change the direction of constituent particles. Those physical properties are refractive index, electrical conductance or dielectric constant. Amorphous solid shows isotropy. That means similar properties in all direction. Crystalline solids are also known as true solids. Amorphous solids are known as pseudo solids, or those are supercooled liquid, and well known example is glass. Glass is a supercooled liquid. See, SiO2 is quartz. So quartz is crystalline, but quartz glass is amorphous. Another examples are rubber, plastic, chalk, those are amorphous. Crystalline metals, some organic compounds are crystalline in nature. So this is what about basic difference between crystalline and amorphous solid. The next part is we will see the form of Bragg equation. Bragg, he was scientist and he deduced a equation to study the properties of crystalline solid. So further we will study the properties of only crystalline solid. That equation is n lambda is equal to 2d sin theta. So question may be, suppose four different forms are given, then which is the correct form of Bragg equation? So you have to predict the correct form of Bragg equation. So in that equation, n is order of reflection, lambda wavelength of X-ray, d is interplanar distance, and theta is angle of reflection. So for different order of reflection, value of n means order, and for that Bragg equation, see, for first order reflection, value of n is 1, equation is lambda is equal to 2d sin theta. For second order, value of n 2, lambda is equal to d sin theta. For third order, value of n is 3, lambda is equal to 2 by 3d sin theta. And for nth order, value of n is n. So equation will become lambda is equal to 2 by n d sin theta. So that equation is given in your introductory part in that solid state chapter.